So for my project for this course, I decided to do the Pearson correlation coefficient. So this is designed for an introductory level stat class. And this is an important idea in determining whether or not two variables have a linear correlation, and whether that correlation is a positive correlation or a negative correlation. So the context in which this lesson is done is that this is a first lesson in bivariate statistics. So we've done a lot of work, as I mentioned here, in univariate statistics. So we've worked a lot with one variable, but we haven't worked much with having multiple variables in play. In this case, two, which is usually all the higher we go in a freshman level stat or freshman or sophomore level stat class. It's not going to be one of those things that we're going to get into multiple explanatory variables and things like that. That's more for a low-level graduate or upper-level undergraduate course. And a big focus of an introductory statistics course, at least the way things are run here at Central Michigan, is that we're going to focus a lot more on interpreting statistics rather than worrying about the mathematics. Can you calculate these things by hand? We have technology today that allows us to calculate these things. We don't need to necessarily learn the formulas, we just need to be able to understand them. And this class is being taught in a flipped classroom format. So throughout the semester, we have lecture videos and then come to class for more active learning activities. So learning outcomes, want to be able to interpret the Pearson correlation coefficient. So what's going on if we have a high Pearson correlation coefficient? What's going on if we have one that's near zero? What's happening if we have something that's close to -1? And we want to understand the limitations of the Pearson correlation coefficient. One of the data sets that I have the students working with is an almost perfect quadratic relation, and the Pearson correlation coefficient on that is very close to 0. That's because of the fact the Pearson correlation coefficient is used to measure linear relations, but doesn't do anything for nonlinear relations. So description of learning intervention. As I mentioned, this is a flipped classroom format, so there is a lecture video to be viewed by the students before class, and I've included that lecture video within my live binder. It's providing an overview of scatter plots so we can plot different variables against each other, and the basic ideas of the Pearson correlation coefficient. I use a few data sets that I actually repeat in the in-class activity, showing what the graph looks like and what the Pearson correlation coefficient is for that particular graph. Then there's a group activity that we'll do during class. Basically, the idea of if the data is not correlated, the correlation's not going to be any worse if I shuffle the y values around to the different x values. Likewise, if it is correlated, I'm probably not going to get too much better of a correlation if I shuffle the y values around. As they're doing the group activity, I, as the instructor, would be going around to the various groups to facilitate some more discussion, trying to take them a little bit deeper than just surface level. As I say, I want them to understand, not just be able to regurgitate. And then if there's extra time at the end of class, I might bring in some real-world data sets. So often, in a classroom setting, we get what I like to call classroom statistics, where we either get something that is very much significant or very clearly insignificant. But the real world doesn't generally operate that way. In the real world, we'll get stuff that's very close to that cutoff where we have to make the decision whether it's or not it's significant. So I like the idea of bringing in real-world examples. So technologies that are being used. YouTube, basically I record a video and put it on YouTube. I do use some other technologies in making the video. I use Desmos to make my graphs, and then I used iMovie to put a little bit more graphical representation in there. And then an web application from the Art of Stat. So as I mentioned, in the activity, we're going to shuffle Y values around just to see what happens with the Pearson correlation coefficient when I do that. And what we end up getting out of that is a graph that looks like this. This is a histogram of the various Pearson correlation coefficients. This is not one of the data sets that I actually used in the activity, but it still gives you the same idea. So we can see here, the triangle on the far right that has OBS on it stands for observed. So we see an observed value that's way up, where the bulk of the values that we get out of it, and we did 100,000 permutations of the Y values here. Various Pearson correlation coefficients are well below that. So that gives us the idea that we're seeing something significant. I always like to stress the fact that seeing stuff that's normal isn't significant. The significant things are when we see stuff that's unusual. Like shuffling the values around, we see that our original Pearson correlation coefficient is unusually high. So that's telling us that there's probably some sort of relationship going on here. So how is this grounded in learning theory? So concrete experience, I bring in several concrete examples to illustrate the ideas. I have 4 different data sets that are used in the activity. 3 of them are also illustrated in the video and basic overview level. Then reflective observations. So I have you generate the scatter plot and Pearson correlation coefficient, and I want you to spend a little bit of time thinking about how they're related as part of the activity. And then you get the abstract conceptualizations. You see several examples. You start to get ideas. When the data is well correlated, you get a high Pearson correlation coefficient, and everything I use here has positive values, so they're going to be high. If I had negative correlation, you'd get a negative value, very close to 1 if there's a tight correlation, or very close to negative 1 if there's a tight correlation. And then lower appears at first to be no correlation, but then I throw that last example in with the quadratic, where we have a low Pearson correlation coefficient, but the data is still correlated, just in a different manner. And then active experimentation, we do all these trials, getting the idea of we have a significant result because it's not likely we're going to get that just from shuffling the values around. So then, how do I assess the student's learning in this? So one of the things I do at the end of the class is a little 60-second essay activity on what the student learned from the activity. Namely, so we get a high Pearson correlation coefficient. That means we have a strong linear correlation. Get a low one, we don't have that strong of a linear correlation, but we might have some other form of correlation that's not taken into account. And then there's a correlation coefficient intuition exercise in Khan Academy, which the whole format of that is matching the scatter plot to the correlation coefficient, drilling home the idea of a tight linear correlation in the positive direction is going to have a high Pearson correlation coefficient, and a weak or no correlation is going to have a lower coefficient. So I'll end by showing the references that I used in this activity.